I did my
Gentlemen,
intro already. You got it
did,
covered. Code
did
nerd.
his intro, code nerd extraordinaire. Um, this is, uh, those of you who've been to the other talks about new construction, it's a little more straightforward. This is very hard to to deal with for existing buildings. The uh, we have this diagram I've been showing for a while that we're shrinking in Seattle the red triangle down to close to nothing in 2050, even while our population continues to increase. I just saw in the paper this morning that we're up in the top few cities for growth again, uh, and 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 still squeezing out all that. We can increase to some extent our availability of clean electricity if we really pull out stops. Um, but we maybe will between now and 2030 get 5% of our progress through new construction. Existing buildings need to do the heavy lifting. The climate action plan puts this into our city law that we're uh, going to reduce overall emissions. This is compared with our 2008 emissions. So ignoring all those tens of millions of square feet of construction that's happened in the last couple decades, we're still trying to get to 45% below that and then continue on down to 2050. So it's a very, very aggressive plan. Um, Getting into the technical stuff with additions, you can have that addition comply, or you can uh, combine the addition with the new construction and have them comply together. Um, uh, One thing is that we've clarified here is that if it's an addition over 500 square feet, then you do need to get C406 credits for that, and you do need to do air barrier testing for that new addition. Alterations, not additions, generally follow that rule: is you break it, you buy it. So, um, but new stuff has to meet the the current code requirement. You can leave existing stuff alone with very few exceptions. Um, and there's a lot of weird conditions that come up with alterations, as all you know. Um, Please, when it's just not gonna work, come in to talk to us. I always say, don't come in empty-handed. Bring in something you're gonna do uh, that makes up for whatever deficiency your project is gonna have, and so we have something to say, be able to put in the record that yes, we got equivalent energy efficiency to what the strict interpretation of the rules was. Um, there are three big conditions for when we have to treat the building more or less like a new building for code. So substantial alterations is Seattle only. Everybody loves subalts. You can either have the UA be 15% higher for that, or um, you could have the do energy modeling and have that whole model be 10% higher than we'd normally allow. Pick one or the other. Um, and like I said, you'd still have to do C406 credits and renewable energy. With change of space conditioning and change of occupancy, the envelope UA uh, alternative is that the envelope is 10% higher than allowed by code if everything inside is meeting the new code. And that allows, there's slab edge conditions and other things that you're just never going to be able to bring up to current code. So that gives you a little bit of wiggle room there. Um, Note that uh, the specifics of change of occupancy, you're taking it from uh, uh, either unheated or semi-heated space up to fully conditioned space, or in Seattle only, you see where the three asterisks are, you're changing it from heated to heated and cooled. We're considering those to be points in the life of a building where some major changes are happening, and that's where we're doing where we're bringing it up to code. Change of occupancy is only from those three funky occupancies, storage, factory, or utility to something more polite, or from something that's not a dwelling unit to a dwelling unit. So the 3 asterisks part, uh, we've modified that since if you switch to heat pumps from, say, fossil fuel heating, you're essentially taking it to being heated and cooled. But we were able to determine that it's still way more efficient than leaving it with the gas or fully electric resistance heating. So uh, we're not going to consider it a change in space conditioning if you're just changing the existing heating to heat pump and you're leaving everything else alone.
Full disclosure moment. I didn't catch on to this change until a year into the code cycle when I got a client RFP that suggested doing such a thing. And I said, you can't do that. And then went back and said, holy crap, you can do that. And then started running around super excited and called 3 clients whose projects had previously died because they were adding cooling to an otherwise heated building. So yes, you can. It's fantastic flexibility for existing buildings and obviously puts you way ahead on energy, but also way, way, way ahead on carbon emissions. So 2 thumbs in the air, was super excited about this.
That only took us 20 years to get there. For subalts, which everybody loves, we're considering this something that happens maybe every 40 years, where it gets a very thorough repositioning in the marketplace, or a big gut and remodel or something like that. That's the point at which we're calling it a substantial alteration, and it's not just energy code; it's life safety and seismic. Bring buildings up to being ready for the next 40 years, and the main definition, there are several definitions of what a substantial alteration is, but the main one is that it substantially extends the useful physical or economic life of the building. That still, you can tell, is a judgment call. So there are 2 people in the department here that are empowered to make that call, and it often involves some very long negotiation meetings, but it's for real. Also, if things have been vacant for a long time, or if they stumble over this impracticality problem, it's still, impracticality doesn't mean you get away scot-free. It means that we'll deal with the portions of the building that just can't be upgraded. We have several exceptions that landmarks says don't touch something, we don't touch it. If it's a URM, an unreinforced masonry building, that all they're doing is fixing the seismic safety of the masonry, that you're scot-free. If it's less than about 20 years old and vacant, we're saying, even though if it's been for more than a couple of years, that's fine. So you can either follow the whole prescriptive code with a substantial alteration, or you can have the envelope be 15% worse, like I mentioned, or you can do modeling and have the overall modeling use 10% more energy than new buildings would require. In tenant improvements, I want to note that first, this is a Seattle only thing, but that first 18 months after you got the certificate of occupancy for shell and core, you can use whatever the code edition was that was in force for this building. So if it was back, if the building was permitted under 2015 and they just opened this week, then for the next 18 months, you can still have the tenant spaces meet that same code. And there'll be more slides on this further on, but if you get C406 credits in your shell and core building for an HVAC system, that the TI space is just plugging into that one that you got credits for, those credits apply to your tenant space. And the final thing to know is that what we just called typical tenant improvements. I think this thing that's happening on the slide is a typical tenant improvement, but you're just doing partitions and uh, other normal work inside the lighting, so forth, inside a tenant space that would not generate a subalt.
Real quick, Dwayne. I
Yeah.
think it was maybe 3 slides ago now. It was the slide before minimum energy performance. Cameron was wondering, is that an exception if switching about heat pumps? Was an exception about switching from natural gas to electric?
No, it would not work if you were going from natural gas to electric resistance. It's you're going from natural gas or electric resistance to a heat pump heating system. That's when that
Okay,
works out. Hope
thank
I'm
you. Let
answering
me
your
know.
question.
Yep,
Okay.
let me know if you got that, Cameron.
Um, so heat pumps in alterations. Note here's the slide that's just about the Washington Code and um, says, yeah, you got to do comply with that section to have a heat pump or meet one of those exceptions. Um, and, and then the exception on the bottom just says, or you can replace your existing equipment with the same type and capacity, which means basically you never have to comply with that. And yeah, Ben had a thing or two to say about that.
Yeah, so there is these words sections, C43.4.6 and subsection, and then there is a table. And the first several times I read it, I was like, oh, that's nice. They took the words and made it a table. No, these are all or statements. So it's or all these exceptions, or all the compliance options where you hit more efficiency out of the table. So mind yourself when reading the code. Those ands and ors really get you.
Yeah, and we'll get into that particular table in a minute. Seattle, we did it differently. We said you have to um, meet meet one of these standards, or we came up with whereas in the last code we said the only exception was that you could replace one piece of equipment on an emergency basis no more often than every 2 years. That was not working out. People were just scheduling those things into their normal maintenance calendars. And we want the intention is, like I mentioned in the first slides, that we're taking Seattle to be carbon neutral, um, kind of clean energy city, and we can't get there if we just keep putting in new gas equipment that could last for 15 years or more. Um, so we did exempt several building types that have um, a special difficulty in funding that you see there on the bottom left. Um, we said you can keep um, half of your existing gas or resistance capacity if you just put up the other half as heat pump and um, and control it so that the heat pump's always the first stage of heating. Um, and we said, okay, and if you're in some real crisis and you have to replace all of your stuff, you can still do that. You just have to give us some assurance that in the next few years you will get get to that 50% heat pump. I'm kind of interested in that as these projects come in, whether somebody who puts in 50% of their existing capacity as heat pump ever uses the gas in Seattle, or if it, in fact, systems have been so wildly over designed um, for all these years that you don't actually ever need to switch over to that gas half. But it's just there, keeps people comfortable. Or the number 4 there is that if you have to trench across a road or install a new electrical vault or something like that as a result of having this, you would you'd also be exempt. And then there's certain small equipment that's exempt, or stream systems. There is this table that Ben mentioned that is also compliance options. And if you get down, see where I've circled in red there. If you just got hot water, a boiler, a gas-fired boiler that was 5% better than that basic standard, you'd be good to go. So there's still some, and this is if you're complying with one of these uh, other exceptions up here, exceptions 1 through 4. Um, we remember I said we had this rule last cycle that you could replace one failing piece of equipment. Like I said, that was not working out. So this is the philosophy slide, asking the question: if we don't do this, how would we get there? We're aware that it's expensive and complicated and difficult to switch from a non-heat pump to a heat pump system. They're more complicated. They need airflow. They need um, often more space and more power. The idea is that if you're doing a major equipment replacement anyway, you might have a crane on the site. You might, you got financing, you've got a contractor involved, uh, permits going. That would be the most economical time to do the upgrade. Uh, there are other things. Some other jurisdictions have toyed with having these replacements happen at time of sale, um, or by some future date in the certain. But it is it's the solution we've come up with that's the least difficult of all the difficult solutions. Um, Here's my little flow chart. Don't smirk, Ben. But the idea is this is for space heating equipment replacements, but the same would apply especially for water heating replacements. So on the left, you see on the top those different um, conditions where we just let you completely out of it. One option would be to just do the heat pump upgrade anyway, or you're exempt, but you have to do what we're calling this future decarbonization plan. If you're some other kind of building, then you have to you only have to replace that 50% of the existing capacity and do that future decarbonization plan. And finally, what I mentioned before, if it's a crisis and you have to replace all of your existing gas capacity, then you could either get a temporary certificate of occupancy, which people would probably use if it was going to be not very long until the heat pump 50% got installed, or more likely you'd get a bond, a performance bond that says that within 4 years you do that replacement. We're fully aware that 4 years is way less than the typical life of mechanical equipment. Um, and the idea was that you'd have 3 years to get together financing and planning, and then 1 year for construction in that. And that plan is fully engineered schematic design and cost estimate. So that's really quite a big deal, and we have to be. This is to ensure that the owner is fully aware of what it'll take to get the rest of the way to having either that HVAC or that water heating system brought up to a decarbonized system, and so the idea was for cost that this, if design is 10-ish% of construction cost and schematic design is 10-ish% of a design contract, then this is 1%-ish of the work that we're doing, of the cost that it would cost to actually do all this work. But then the owner will have in hand, and we'll have a copy of something that shows how it looks like you'll get there. I'm guessing this could become kind of a cottage industry for some design firms to be able to do these future decarbonization plans. The planning form, item H, that you see there, after a long delay, is finally getting posted right around now. So you have that to fill out. Here's another big deal that in Seattle, we're saying if you're replacing an air-cooled chiller, uh, then that replacement has to be a heat pump system that is serving as the first stage of heating. So it would your chiller is now being replaced by a heat pump that's going to be controlled together with your heating system, so that you can go into heating mode and and um, and use that for heating. The idea being that you'd certainly have the power there for being a heat pump system if you've already got the power there for it being a chiller, and it's got very similar exemptions to the other things you've just seen. We do have, which hasn't changed a lot over the years, still this chart for adding cooling to an uncool space. So we're providing, you got to either have a DOAS or an economizer system, uh, and and do that for both the individual pieces of equipment and the total system redesigns. So you have this long table of which you just see the top there of economizer compliance options, and the only change for Seattle there from the state code is that we fixed a few of the footnotes. TSPR is another big deal. Total system performance ratio. Ben's going to have something to say about this in a minute. The idea being that we're looking at the overall performance of your HVAC as compared with what we in our wisdom have determined to be pretty good systems. And I just did get, this is all done through a software system that's free, available online, and so they can track these. And they told me that 19%, so about 1 out of 5 projects, fails the first time through, and they do have to go back and make changes to bring the overall level of efficiency up to where it should have been. So it is taking an effect. Sometimes you have to use larger ducts to get your fan size down or something like that. That's gonna bring you within bounds. Commissioning is another thing for existing buildings that's we have to watch out for, and it follows the same kind of new construction rules. So you see those different thresholds there for how big your system has to be before it needs commissioning. So if you're doing an addition or an alteration that replaces or changes out more than those threshold amounts, then you would need to do commissioning. And if you only have 1 or 2 of those 3 things, you'd just do the commissioning for those 1 or 2. You'd still need to be doing that.
And that's cumulative for your project. It's not like a 240 ton, or sorry, that's heating, but it's not a 180 kBTU system or larger. It's if you did many, many small systems, you're still there.
Right. Within that project, it's the whole deal. You're right. And so we've tried to make this more clear with the Seattle rules that you need to note this on your permit documents, in particular on your mechanical permit documents, that commissioning is going to be required, so that the inspector has something to see on the drawings there. You have to have the commissioning plan submitted before you get your first mechanical inspection. So that was recognizing that you can't always have the commissioning plan done when you submit for permit, because you might have not even selected a mechanical contractor yet. But before you get a mechanical inspection, you got to have the plan in, and then you got to have the report in before the final inspection is signed off. So those are important. But what's a really new thing for Seattle in this code version is that for things that are on the commissioning that are not finished when you leave, when you're finished with the building, you want people to move in, and there's still a few of those nagging things. You're waiting for some part to come from a long ways away, or you have to wait until July before you can test the cooling system under stress conditions or something like that. You can't just shrug and walk away anymore. So you either got to get a temporary certificate of occupancy. You you could get a bond for 2% of the whole project valuation that you would be returned to you when uh, you demonstrated you finished the commissioning. Or what's more likely, that you take out a new mechanical permit, and and anything else that needed to be done would go on that permit, including all the unresolved, unfinished commissioning work. So that ensures that the commissioning doesn't get just dropped. And this is a really big deal for as kind of a consumer protection thing, because the owner already paid a fortune to get all these fancy systems and controls in there. And if they're not doing what they're supposed to be doing, then we want the contractors and the subs to keep at it until it does all work and the owner gets what they paid for. Completely different thing now, away from the code, whereas our code requires heat pump or one of those other options as you're replacing systems with some options. The BEPS, the Building Emission Performance Standard for Seattle, says that in 3 different stages you have to reduce your carbon emissions from an existing building, and getting to where in the 2040s the building has no more carbon emissions. The Washington BPS, the Building Performance Standard, was set up so that around 60% of buildings had to reduce their overall energy use to get down to that threshold that they've set for what they consider a pretty good building, which is that 60% line. So buildings that are close to that line might just be able to change a few procedures within the building, how when they turn the lights on or off or whatever it is, and to reduce their energy use. But others that are missing it by a long ways are going to have to do system upgrades. So we've set things up so that you can postpone, in many cases, the energy code compliance, uh, or you can decide whether to pay now, do it right away, or wait until you run into the BPS or the BEPS policy deadlines. And so that's just kind of basically a summary that Washington requires these below average buildings to come up to at least average, meet this EUI target, or pay the substantial penalty, right? $1 a square foot a year. Whereas Seattle's saying we've got these CO2 emissions that we're going to, any building over 20,000 square feet has to start moving up the ladder right now and getting rid of those emissions one stage at a time. You can see the building performance standards for the state are specific date certain times that you'll have to get those going, whereas the BEPS for commercial and for multifamily step down in roughly 5-year increments, heading towards zero carbon. The cool thing about heat pumps is that they both dramatically reduce energy use and reduce or eliminate carbon emissions. So by doing that step, you're taking care of both of these. And finally, we got still until this program sunsets in the fall of next year, buildings still have to do these tune-up ordinances, tune-ups, where they go through and they just look at all the energy using systems and fix all the stuff that is easily fixable. And that is going away because the BEPS policy pretty much takes over. People are going to be monitoring their systems much more closely in order to comply with those. Now, with a lot of talking from me done, we get to hear from our engineer, Ben.
Every once in a while, I get to say, not that kind of engineer. much as my son would wish me to be. Um, all right. So starting in C503, the existing buildings chapter, you get pointed at C403 for anything you're replacing in the mechanical world. And I like to say, if you break it, you bought it. If you're replacing it, you own it. You got to go back to C403. And C403, right at the top of the section, has total system performance ratio that Duane already mentioned, and some dedicated outside air with energy recovery. Yeah, there's the engineer version of a, or the engineer by way of marketing version of a flow chart. So you've also got energy recovery ventilation requirements or some exceptions. It's a rather long list for both of those. But if your specific occupancies and you trigger TSPR, it's it's path. Duane said 1 in 5 buildings fails. I don't know if that's all or just existing buildings that they're reporting back on. I would expect higher than that. We have many projects where we've said, great, we're replacing the mechanical equipment. Oh no, our TSPR doesn't pass, and it's by enough of a margin that we need to go do something else in that building to save energy. Lighting, sometimes windows, air seal. There's a wide list of how you get down below your TSPR target. TSPR, because it's emissions based, also depends on what your mechanical system you're putting in is versus the assumed baseline. So if you're not meeting your TSPR and you have an exemption to use gas, you might not use that exemption. Going to a heat pump can be one of the ways that you get your emissions portion of that calculation down. So all in all, it's pushing for better building performance in existing buildings, which is part of the purpose of the code. DOAS, I want to show you a couple quick slides. So like this is every mechanical engineer on the phone is gonna roll their eyes, but it's important to say this. Conventional systems took return air, mixed in outside air, reconditioned the whole thing, sometimes overcooled and then reheated at the zone level. We weren't thinking hard about energy efficiency. So what is now required by DOAS, hit the next slide, takes and separates the indoor heating and cooling loads from the outside air heating and cooling loads and requires that we do energy exchange between the exhaust, like bathroom and the like exhaust, and the incoming air such that we get back on the order of 65 to 70% of the energy that we were throwing overboard in old buildings. We were just exhausting those bathrooms out instead of trying to get some of that energy back. So it is actually a lot more efficient. There are ifs and wherefores about making a general statement like that we won't do today. But if you want to ask questions, I'd be happy to get into it at the end.
So
Ne
are you able to downsize your heating and cooling equipment based on the fact that you're getting back energy as it's exiting the building?
So HVAC equipment tends to be notch E. Like there is a capacity and then another 150% of that capacity, 200% of that, So often, yes. So the outside air and the latent loads of the space, because we're doing energy recovery and get the humidity part down, um, can drop so dramatically that even though we've now got 2 pieces of equipment, our total electric demand and certainly electric use are lower. Our equipment sizing, HVAC loads are lower, and uh, you got to watch yourself on HVAC loads for the non-mechanicals in the room. There's a lot of ways to move that number around. But yes, generally we are smaller now than we were. We're one size smaller when it works. If we were right up against the capacity, sometimes it's not. But mostly, yeah, we get to downsize a little. Cost savings on the indoor equipment. We now have 2 boxes, so it's not so bad. It's not as spendy as it might sound. Uh, if you do not have a DOAS requirement, you get to keep doing old school economizer like back in the day, like what I started my career doing. Um, and Duane already mentioned this giant table, and it really matters. Did you have an economizer, an ability to 100% move all of your air through your unit from outside air so that you can use free cooling? I put in air quotes because you're still paying fan energy, but free cooling or not. And there can be like air balancing uh, questions, particularly on big buildings with built up air handlers. It can be impossible, and you're trying to do one of these other options to get yourself there. Next one. So fan coils, VRF, and the meaning of life. Duane asked me to talk a little bit about, and this was when we did this presentation to begin with, about how do we get it done? What are we doing most of the time? And that answer is in flux right now because of refrigerant changeouts, which we'll talk about in a minute. So, what is the answer? How are you getting it done? I couldn't help Douglas Adams reference. The answer is 42. But it really matters. Do you have TSPR? Do you need DOAS? Can you not do DOAS? What are you doing for equipment? The answer was often split systems indoor, or even a rooftop unit indoor without any outside air, and then a separate energy recovery unit. And for flexibility, just for the ability to go very high or very low, or lift from ground level to 10 stories um, the answer was often VRF. It just is. And let's do the next slide. We're doing a refrigerant changeout that makes all refrigerants A2Ls, which are very lightly flammable. Ask at the end what my fire protection engineering side thinks about this changeout. Uh, but um, but with that, we also get a bunch of requirements for fire-rated chases. VRF is a lot more complicated because you can release enough of a charge into one room. There's a lot to address there. It is no longer automatically a leading contender for what we're going to do in an existing building changeout. All right, water source heat pumps. So if you got water source heat pumps, you basically have your cooling and heating, and you run a medium temperature loop around. So you got a low temperature boiler loop would be another way to say that. You got not, you don't cool, you don't chill that same loop to that low. It is highly effective. It is a possibility. It also has a serious cost requirement. Uh, when compared with VRF, it is usually a far more expensive option. We are seeing an interesting hybrid now with the refrigerant changeout where you run a water source loop to floor by floor water cooled condensers and then do VRF out on the floor level where you don't have to build fireproof chases. So water source heat pump has made it an interesting recovery, reintroduction. I've got some young engineers who've never done one, but we're doing it now because we can't run refrigerant more than 2 floors without jumping through a bunch of hoops. Last note, dual duct changeout. I saw the first one of these when I moved to Seattle in 2008, and I said, what the heck is this dual duct thing? You mean you completely cool the air and heat the air and then mix it back together to get a neutral temp? Like, what kind of craziness is this? And my boss laughed at me and then had to explain it. Um, oh, my slide didn't change, Duane. I'm still on water source heat pump. We should be on. There you go. Um, So you got a bunch of big ducts there, and you are not allowed to simultaneously heat and cool in the current code. So you get into a real sticky if you're only doing a single zone or a single TI, you're trying to use exemptions. Pretty exciting. Or you're trying to do what is allowed for VAVs, where you take the cold side air and then reheat it locally. It, it is no doubt a sticky situation. And sometimes you get out of it just by saying, well, great, that TI we're going to take off of the main mechanical system and put in our own. It's all an if and therefore. But let's just be clear, it's a really horrible system from an energy perspective. Okay, next one. Being difficult. This is our now 4-year-old son from back when. Existing TIs that are super difficult. Hospitals, labs, manufacturing, other high occupancy spaces like assembly spaces, theaters, things like that. All of them have requirements in C403 that apply and make a direct replacement. Even though you've got exemptions in some cases, doing a direct replacement, you start triggering a bunch of stuff. So it is a problem. Uh, Chillers. So heat recovery chillers are just now getting their act together enough that we've got like industry standard ratings that you can make medium temperature water for what is normally 180-degree boiler water for you're required to be a heat pump that Duane talked about. It is coming together though, and I mean, literally last week I got my new lowest temperature operations minus 20 degrees, and the last time we did this presentation, it was 12 degrees, 2 years ago. So it is coming along, and it's coming along nicely as an industry. There's new products every month. All right. So if you're replacing your condensing boiler and you're already a less than 140 degree loop, sometimes 120 degree loop, you might be able to get there now without putting a backup boiler or without using your 50% allowance of your gas, just because of where chillers have come in the last 2 years. I couldn't say that when we did this 2 years ago. Couldn't say it, but it is really exciting that you are now getting there. Um, some other ways, even if you're doing a central plant replacement, looking at energy recovery on your ventilation, starting to do some of your air side, even if that's not originally part of your scope, can help you get those loads down or get the temperature needs down. Um, let's go to the next slide. Where it doesn't work so well, 180 degree boilers. So right now the only heat pump solution we have are cascading loops, and several people make these. But you basically run an air to water heat pump and then another water to water heat pump to boost that water temperature up to the 180 you can make. And it's not an energy efficient or particularly good solution. Sometimes you can run that 180 degree loop. You know, Duane said, yeah, these are often oversized. That's true. So sometimes you can run that down at 160 and fully heat the building. Sometimes you can do a temperature delta, but if you're only keeping 50% of your gas, you got a sticky thing here. Um, let's go to the next slide. Engineers in the room, this one's for you. Log mean temperature difference. You can't just like be like, sure, I'm turning down from 180 to 160 and I'm sure it'll work. You got to start evaluating individual coils and what they work at with that. You got to work with your rep. You can't just assume the delta T moved down and I still get the same capacity. It doesn't work that way because you got your airstream temperature and your coil temperature to deal with, and the closer they get, the less heat you get, and it's logarithmic. So mind yourself. That's a painful lesson from me I can share with the world.
I wanted to ask, I've had sales reps coming in lately with some brand spanking new thing that they say they have heat pumps that can boost water temperatures up to 170 or something. Is that real yet? Do you know? Or is that still
It
imaginary?
is, but it often has an operational envelope that it can do that down to 30 degrees, 35, and then it starts dropping off as it loses capacity. So yes, it can, and no, it's not really effective for Seattle, and certainly not effective for east, east of the mountains.
So when you actually need the 170-degree water, you can't get it.
Exactly. Yeah, it's a fine print detail. High temp water, i.e., above boiling, which is a rare system. You don't see it much anymore. It was big in the 80s. And steam, we don't have building scale heat pumps to do this yet. There are some utility scale heat pumps in Europe that do uh, steam generation by heat pump, but it just doesn't exist. And there's so few buildings that I'm not sure when it's going to exist. So you're hoping for an exemption. You got some good exemptions to use there, or you're doing full system replacements because the steam coil and moving that to hot water, it's a full coil and at least half the piping replacement of a building. So it's a lift, and I don't want to minimize it, but you're probably just into a whole system replacement.
And yet,
All right.
any existing building that is still actually having piped steam around the building has been probably looking at getting rid of that anyway, right? Because
Yeah,
it's
it's got maintenance items. It's got acoustic issues. It's except for process, we don't see a whole lot of steam. We're seeing steam to heat exchanger at the building basement and then hot water through the building.
right.
Uh, and sometimes that's just a matter of it's low enough temperature, it's fine. And sometimes it's at 180 where you gotta, and it depends, and you gotta start really evaluating what the system can do, what the original loads thought they were, and what it actually is. It's all interesting. Two pipe changeover, the cheapest of the cheap systems. You run cooling in the summer, and then you turn on the boilers and turn off the chiller and run heating in the winter. It's all through the same pipe, and so that's not great, and certainly has occupant comfort issues. But it presents this super exciting thing where you can say, oh, great, I'm going to start running it as a water source heat pump loop because you have a similar delta T. The pipe sizes don't change if the piping's in good condition. Put an air to water chiller on one side doing those low temp or medium temp loop temps. Put a water to air, water source heat pump on the other side. And all of a sudden, your super low budget like all of us shake our heads mechanical system becomes state-of-the-art water source heat pump loop. So you got some retrofit possibility in those old, often not so well maintained, so check your piping, but in those old systems that all of a sudden you're money ahead for having this old kind of horrible system. I love it when we get to do that.
Wait, are those the ones that had steel pipes that are now all getting corroded down to really skinny
That's
pipe?
It's all about water treatment. If your maintenance people were on it, those pipes can live a 40 or 50-year life. And it's usually only at like central plant level maintenance folks who are really deep into their water treatment. Ground source heat pumps, sewer heat, other sources are allowed. They are highly encouraged in some cases. You actually get out of things like TSPR for doing some of these. Um, and I don't have like a strong, I often cannot make an economic case for most of these for how it has any sort of payback in any near future unless you've got a constant need for heat from like process instead of building conditioning. So great. We have also looked at but could never get the permit. We did a couple ferry terminals on the sound, and we want to do heat exchange with the sound itself by way of a titanium heat exchanger. It was the only thing that put up with it, but could never get the permit to do it. Although I have heard, and put it in the chat if anybody actually knows if this rumor is true. I have heard that the recent aquarium edition was actually able to do that, and I want to find out who knows and how they got their permit because that's exciting for any near waterfront building.
I wanted to throw in that for ground source systems, that's the only system we have that could actually take excess summer heat and store it in a way that it could be pulled back out in January when it's cold and dark and you need that heat. It's very highly effective. It's used in Northern Europe extensively. Real expensive to drill those holes though.
Yeah, I am currently in the middle of doing that at my house, and I'm willing to take an 18-year payback on my bore wells, or hope that I sell it for more if we don't live there 18 years. But
Well,
those are those are personal choices. Those.
also, your neighbors probably hate you for that drilling noise that
I,
went on
I
for a
had to get
while.
special permission. It's only 2 days, but I'm having to get special like signed forms from my neighbor because the drill rig is so big relative to a city lot. All right. A lot of exceptions. TSPR. So again, TSPR can be a real thorn in your side if you're doing mechanical only because it can be like, all right, you gotta upgrade more than just the thing you were planning to do on your project. But with these exceptions, particularly this one, like if you do a heat recovery chiller, ta-da, no TSPR. If you do ground source, not the right fit for every TI, but if you can do ground source, suddenly no more TSPR. So you got to look at like if you step up your mechanical system a little from what might be a normal TI, you got an overall energy savings and an overall cost savings potential in some cases. Make sure you're really living and dying by those exceptions. Last one. There you go. We'll take questions at the end. That way we know we get to our end because we started 10 minutes late.
All right. We'll get back to boy genius there. Leaving HVAC for a bit. Lighting alterations have we've set up this system so that we're trying to keep the alterations requirement proportional to the scale of the work that's happening, but keeps bringing the lighting systems closer to current code. And my thought is we've had substantial decreases in overall city light power draw for like the last dozen years, and I think a lot of it has to do with the fact that so many commercial buildings have already switched over to more highly efficient lighting. But if you're only replacing light fixtures and you're replacing 20% or more of those in any space, then you just have to make sure that the lighting power allowance for the whole space is within that our standard, which is anything that's LED, it's gonna be doing fine. If the second stage is if you're wiring new fixtures or you're recircuiting existing fixtures, those those then you have to put in all those controls that apply to the whole space. So the switches and that 50% switching, the daylight zone, um, occupancy sensors. Those are all things that you'd need to upgrade for that space if you're rewiring. And then finally, if you're doing a whole new lighting panel or moving your existing and raceway with it, so you're looking at a big gut and remodel project somewhere, then that would also include the automatic time switch uh, uh, system that would be required for new construction. Controlled receptacles in alterations are required uh, for that list that you've got in the code of typical spaces that require those, and then would require half of new outlets to be controlled with the time clock or the aux sensor. Um, so outlets that are being left alone in the existing space would not require this, and alterations smaller than 5,000 square feet would not require this. We picked 5,000 basically because that's just the point in Seattle that at which plan review starts to kick in. So there are a number of exceptions. You just this is like slowly getting us towards a way we can use controlled receptacles. Metering is required in alterations first for major HVAC alterations. So if you're doing an overhaul that involves more than half of your heating or cooling capacity, then you're going to need to set up metering to meet the code requirements for the incoming power and gas and sub-metering for the HVAC system with the normal data acquisition system. If you're just doing a specific uh, one piece of equipment and not doing this whole system replacement, then you'd need the kind of meter that you'd put on a piece of equipment where you'd have to come around with a clipboard and write it down. It wouldn't be tied into an overall system. The idea being that if you keep doing this one large piece of equipment at a time, eventually you'll have a metering system. And of course, if you're doing a really major overhaul of a building and you're ripping out all the old funky wiring, then you do the whole metering system per code. A big confusion in buildings is what do you do with C406 systems? For like I mentioned, for those major overhaul uh, uh, systems, you'd need to get uh, C406 credits as for a new building, not for just typical alterations. Tenant spaces, note that where I put a little arrow there, that if it's a tenant space that's just rolling over from one tenant to the next one, then those C406 credits would not apply. So if you are doing tenant spaces and you've built out an HVAC system that got credits for being above code, and you're just hooking up to those, then you can get those same credits that the shell and core got for those things. In Seattle, we don't allow C406 credits if it's fossil fuel equipment for HVAC or for water heating. Uh-oh.
If you're only going to screenshot one thing for the engineers and architects in the room, do this one so you can digest it at your own leisure with the code and a little whiskey later. It might take both. So I did what is most likely, and then there's a bunch of ifs and therefores about by occupancy and TIs. And again, TIs have to get these points too. it's important to note that if you have to do this, but you can't use envelope measures if they were not a mandatory envelope upgrade, which is those, change of occupancy, change of use, large things. If you didn't trigger that, you can't use any of the envelope ones. Even if you're upgrading the envelope, you can't actually use them for the C406. It's also worth noting that TSPR is a lot of points, and it actually allows to scale above the points shown in this total. So make sure you read the math on that, because your TSPR, which again in existing TIs, in existing buildings, is sometimes just a squeaker just to get the minimum. But if you can get up on TSPR by going to different systems or by improving otherwise, you can get a lot of your points. You can get substantial points that way. Um, there's some other things here that are super great points wise, but like take elevators. I've never actually been able to get that documentation from the manufacturer. So it's like, yes, we probably are that in a lot of cases with highly efficient elevators. And if you can't document it, it doesn't exist. Process wise, make sure that you're actually talking about this early in your design. Make sure you're running your TSPR early in design. This is a trigger to do that as well. If you wait until 90%, you're like, great, gonna do my code package. You're doomed. You are so far behind the ball. So have fun. Screenshot this.
All right. Um, Getting into a few envelope issues. Um, we used to just not deal with roofing, but we wanted to make sure that we're getting the uh, compliance with the rules that say you have to uh, use re-roofing for to get the roof insulated. So we have a couple exceptions there, but it gets a little complicated the way it's been worded. But if you look at my little chart there on the right in the dark blue, your framing cavity is either exposed during the project or it's not exposed. And on the top, the sheathing or the insulation has been exposed or not exposed. So note that a roof replacement is different from a recover. So if you're doing one of those projects where they're just putting another membrane over the existing roofing, that doesn't trigger these. But where they're peeling it off, you can see well that we're taking that as the opportunity for bringing the roof up close, but maybe not all the way to full compliance. We will work with you. Sometimes you've got, you add the insulation and it would prevent you from being able to open the door from the penthouse or causes problems with the edge conditions around the roof. And we'll work with you on that. You can find ways to get good drainage off of everything and still get most of the insulation that we're asking for in. It's highly variable between buildings. There are a few exceptions to the alterations rules. You can replace that pane of glass that just got a baseball through it. And if you've opened up walls, exterior walls, and they're completely uninsulated, all you have to do is just fill those cavities with insulation. You don't have to do any of the further work that we would normally require. If you're just taking out a door and putting another one in the same opening, you would not have to add a vestibule. So there are a few basics there. Air barrier testing we typically do not require for alterations. Note that we do require them for additions. And for those big three, the change of occupancy, space conditioning, and subalts are tested. Do you know what you're looking at there? There's for it looks like it must be a warehouse with 27 fans all set up to pressurize at the same time. Must be a huge space. Very difficult to do warehouses with garage doors and get them to.
It's got to be an insane amount of leakage, or like an Amazon scale warehouse. It's one of those.
Yeah. By the way, people find that if you look at the way that those overhead doors are typically installed, they stop those side tracks a couple inches above the floor slab, and so on either side of every door is a completely open little 2-inch square. And if you're trying to pressurize a space, that is just a killer. So you have to detail those openings so that they bring the tracks all the way down to touch the slab so that you can get a full seal all the way around it. I think this might be my last slide, but people have asked if you're going to need a complete city light service upgrade if you switch to heat pumps. It is highly variable. We're working with City Light right now on perhaps doing a study to see which kinds of buildings would need that upgrade. Note that uh, the original design is based on longstanding electrical code requirements that typically way oversized systems. For existing buildings, uh, you can simply monitor your electric usage for a period of time and and add 25% to the peak load, and anything that's any capacity that's above that is available for doing heat pumps or plugging in EV chargers or whatever you need. Um, and so it might very well be that your building actually can handle this if you do that uh, uh, if you do that monitoring and test for it. Another thing to note is a project that's been going on at NEA, Northwest Energy Efficiency Alliance, for the last several years, what they call very high efficiency DOAS upgrade, where they've taken a number of typically low-rise buildings and switched their system over to a DOAS system, and they found that not only did they uh, eliminate all of their fossil fuel usage for those spaces, but they did not upgrade, they did not increase their electrical use at all. And the reason being that traditional systems have been incredibly inefficient. Fan energy, reheat energy, many other things that engineers have traditionally been doing for generations, that once you've gone to an efficient system, you might find that you didn't need to upgrade at all. So that brings us to the end of the main thing. And before we do a wrap up with Katie, do you have questions out there? Katie, do you have questions lined up for us?
I do. There are lots of questions. Um, oh, now is my mic working?
Yes, you're working.
Ah, good. There are lots of questions, so I'm glad we've got time to get to them. Um, and this is actually about a couple slides ago, the air barrier testing. When you've done an addition, does the air barrier testing have to be done for just the addition or for the whole building?
So it only has to be done for the addition. It can be done for the addition and include the whole building, but note that most additions have a wall between the addition space and the existing space and a door, so you could pretty easily seal that off. If it doesn't, then it's not a problem if you have designed in advance where the barrier will go for the air barrier testing to separate the new and existing space. So just think about that.
It
Okay.
also speaks to your air barrier enclosure likely should come in even if it's not an exterior wall. You want to think about air leakage to the existing building too when you're planning for your
Right.
testing.
Right.
Good point. Okay. Is there a level of improvement in HVAC that eliminates the envelope 15% of code requirement for subalt?
Well, remember that for the subalt, we're saying you could either make have your envelope be 15% worse than code, or you could have everything looked at through modeling and have the overall energy use be 10% worse than code. So I think the
Here,
questioner might have inverted those.
maybe, but I need to be clear. The code no longer allows you to just like pay for bad envelope with great mechanical lighting systems. it has a UA backstop in C407. So if you're energy modeling, you still have a UA backstop. You still have an energy backstop that you are that you are that you were stuck with, and you're doing it on a uh, go watch the new building to get into the deep discussion of this. But you're doing on a building performance factor that on many cases is a harder target to reach than anything you could do prescriptively. So in almost all cases, you're going to choose Duane's 15% worse than code UA factor, and you won't touch mechanical systems. The mechanical systems still have to meet C403 if you're replacing them. And if you're replacing the envelope and mechanical, you got to go talk about substantial alterations. But that's all in a discussion, and they sort of stand alone if you're doing the UA backstop.
Right. And if you're not familiar with what Ben was just referencing, as a backstop, if you're using energy modeling, since energy modeling was traditionally only used to be able to permit a worse envelope, we've capped that so that it can no longer in Seattle be more than 10% worse than the prescriptive code for heat loss, the overall UA, and statewide it's 20% worse.
Right? Duane has a picture of a beautiful glass tower on the slide when he talks about that you likely cannot build anymore, at least where it's all view glass. So
Right.
Yep, that's in the new construction webinar you all did a couple months ago. If you go
right.
to the Lighting Design Lab website, there's a recording. You can watch it. Um, okay, and wanted to be clear, is subalt not triggered if adding cooling if you are switching from natural gas to electric heat pump?
Truth, and so exciting.
Okay. There's not an emoji for like exciting things, so do what emoji you will,
Don't you
audience.
have the high five, two hands
I
in the air, whatever it is? It's
I
super
wish there.
exciting.
Oh, there's clapping. There's
That'll
clapping.
work.
Yeah,
Okay.
yeah.
And again,
And
it took me the better part of a year to catch on to this, but it was so exciting when I caught on that,
it is
we can
sometimes
heat
hard
pump.
to it's sometimes hard to differentiate when an engineer is excited, but you look carefully, you'll see it.
You can see it. You got to watch their pupils get bigger.
Okay, and this I think was answered, but want to be sure. So when adding cooling to an existing conditioned space that only has heating, there seem to be two applicable sections in Chapter 5, 5 C50 505.2 and 503.4.2, which requires DOAs or economizers, including exceptions. Are these sections additive?
Typically, you have to
Uh,
complete the whole code.
yeah. So hold on. Are they talking about Washington or Seattle? Got to start there.
David, that's a good question. If I think he's still on. Oh, nope, he's not on anymore. He can get his answer later. I'm sorry, David.
No, you're fine. So read the sections again. Sorry.
Okay. C505.2 and C503.4.2.
I'm thinking that's a little bit more analysis than we can do on the fly with an audience waiting.
Yes.
Okay.
Yeah. Take the
All
next
right.
question. I'll come back.
Okay. Can you speak more about the terminal unit exemption?
The idea, and my engineer online can uh, set me straight, is that uh, if you have like terminal units in a VAV system around scattered around an office building that each have electric coils in them for heating, um, to switch that to heat pump is kind of outrageous. So those kind of uh, the terminal unit is just like it says where that air is coming out into the space. You would not We would not require that to be upgraded typically.
Yeah, and you're sort of tied to the existence. So think VAV box or a fan coil on a four pipe or two pipe changeover. You're tied to the system you were in already. It's not a could not be done in all cases, but it's often a like, am I gonna put in a split system for this teeny TI I'm doing on this giant central plant? It does, you want to address the central plant, so you're actually making it harder later. Okay. 505.2 is change in space conditioning, and 505.4.2 is if you're just doing building mechanical systems. So it's really two separate questions you've got there. Both point you back to C403, and change of space conditioning actually points you at a lot more than that. So they're independent. They're not cumulative, to answer David's question.
Okay,
And
I'll
and
email him after
in
this.
each case, if David is talking about a conversion to a heat pump system, then we will have run into that issue where just by trying to upgrade from say electric resistance or gas heating to a heat pump, they've made say an apartment be both heated and cooled. Do they have an exemption there? And it's something we got to work out.
Okay. All right. Is TSPR required if modeling is done?
No.
It's
That
two
was an
separate
easy one.
pathways.
Okay. All right. And Gia wanted to
From
know for
from chapter
oh,
5, you are actually pointed at both, so it is a valid question. When you're new building, it's very clear that no, they're not. But from chapter 5, you could say they're both pointed out and called out. That said, your energy model is so much harder than a TSPR pathway that it wouldn't matter. You would pass TSPR, and that takes a couple hours to input for most buildings. So, eh.
okay. And Gia wanted to clarify if, oh gosh, I don't remember what slide this was from. If the old equipment was above the threshold, but the new system based on actual load calcs is below the threshold, you can avoid commissioning step.
Yeah. If you're
Okay.
below the threshold in your project capacity, not just that piece of equipment, you do not have to commission regardless of what the old equipment was. It's the new equipment that
All
is the
right.
triggering.
Oh, thanks, Gia. She heard that and got it. Cool. And get your laugh emoji out, guys, because Cameron wanted to know, Ben, you're not a train engineer, but you are training engineers.
Oh,
So
Okay.
so I've learned with children that the less sleep you get, the better you think your dad jokes are.
Oh, yeah, for sure.
Something to think on.
Yeah, yeah. Okay. David was wondering if you'd heard of any open loop ground source systems being successfully permitted in our area.
just to
I know.
clarify, what they mean by open loop is that you're actually taking groundwater in and putting heated or cooled groundwater water back into the groundwater, and it requires lots of negotiation with the state agencies. You probably don't want to go there.
And some extra super fancy heat exchangers. I only know of one project that tried it, and I don't know if it was ever built. And it wasn't
Oh,
ours.
okay.
Yeah, if
Dave.
you're doing ground source with a closed loop, then you have control over what's in that water, and you can. Whereas when it's coming in from the wild, a couple hundred feet down or whatever, ugh.
Get some mineralization and awfully weirdness in your heat exchangers. Yeah, it can be technical issues of doing that. But it's the re-injection that we should all be going, wait, you're re-injecting water into the aquifer?
Right,
Wait, that's the hard part.
right. And then Cameron, who has been a wealth of information this whole time, wanted to let you guys know that Northwest Maritime Center has a titanium ocean source heat exchanger, and the port is considering one for Pier 69 and 66.
We know because we've been looking at their energy model.
Ooh,
Maritime, sorry, maritime
Northwest
what?
Northwest Maritime Center,
I know who I'm calling tomorrow.
right?
I have a how
Um,
did you get a permit question.
oh, and Cameron provided a link. Here, let me copy it and put it in I'm going to put it in the chat. Everybody, you can access the chat, you just can't use it. Um, Let me put it in the link so you can. anybody can check that out if they want. And
That's super exciting.
okay.
Thank you, Cameron.
Oh, and Gia knows about it too. It's in Port Townsend. Okay. And it looks like this is the last question. Steve was wondering if it's nearly impossible to obtain the efficient elevator equipment documentation, then maybe we should modify the document requirement for that TSPR measure, or is that a rule modification or a Muni code modification? Excuse me.
We can change codes, but we would have to have some other means of determining for sure what the efficiency of that system was, and we gotta not be giving away credit for things where we can't verify that it's really exists.
Yeah, in a way to not game that by you have your rating that makes your particular peaks. I What they're asking for is not unreasonable in the code. It's just a matter of getting your hands on it that seems to be the unreasonable part.
All right, that is it for questions. Yeah, if we go up to my next slide, then people can go in the questions, little question, find the little question mark and ask if you think of anything while we're going through these last questions. The lab has a couple of upcoming events. We are in the middle of scheduling the distributed interconnection handbook training. We had it scheduled, but it got pushed back. That's our new solar interconnection stuff. It's for other things, but basically solar. And then we're going to have a very cool webinar on passive first design, passive house for all the buildings. Oh my gosh, I had his name down. Mark from Mithun is going to be running that one. And then City Light has some Trade Ally office hours, which are very valuable time in front of um, the folks that run our incentive programs. So you can ask questions on what's the status of my project, or did I fill this paperwork out right? That's the third Friday of every month. And I sent our newsletter out this morning. So if you didn't get it, you're either not subscribed to it or it went in your junk folder, which is annoying, but it happens. So check for that. If you're not subscribed, go to our website and subscribe, and you'll find out about, for instance, when the distributed interconnection handbook training is going to be rescheduled. And that is all I have. There's a survey as soon as I close this webinar. It pops up in your browser. Please take that. There's a question on there. What else could we do if you want to learn more about DOAS, or um, maybe something about the Maritime Center? We'll get somebody in and talk about that. Put that in there, and there's all of our contact stuff. Did you have any last thoughts or anything you need to close out, Duane or Ben?
I think we're good to go.
Cool.
Be in touch if you got questions.
Yep.
Yep. And as a reminder too, we recorded this and I'll get the slides up on our website within about a week. So if you didn't screenshot that table, you will have a copy that you can print out, post on your cube wall, whatever, put on your fridge. All right. Thank you, everybody. Thanks for the grace this morning, and we will see you in June. Have a good
Bye.
day. If it will let me close, sometimes it doesn't. Oh my gosh, there we go.